Welcome to this Key Stage 4 Combined Science Higher Paper lesson on reflection and refraction. So our key terms that we need to know are medium, which is the material that a wave is travelling through, for example, air, water, or glass. Now, a medium isn't always a material. The medium could be a vacuum, which is just emptiness, nothingness. But in general, it is what the wave is travelling through. Reflection is when a wave bounces off a surface, and refraction is when a wave changes direction as it enters a new medium. Now be very careful with these two words. People often confuse them. Just remember that a reflection is something you see in a mirror. Refraction is something you see through your glasses or a telescope or binoculars, or when you look into a fish tank. So here is a GIF showing us the reflection of a wave on a wall. So what we have here is, it could be a piece of string or elastic, or it could be a chain that is fixed at one end. It's tied to the wall in a fixed location. If you cause a vibration where you force the string up and then down, when it hits that wall, it will bounce back off again. It will be reflected by that wall, as you can see in the GIF. Reflection is when a wave bounces off a surface. So let's look at some water waves bouncing off a surface. So if you imagine a set of waves headed towards what in grey there is a wall, you'll see that those waves, we're looking at them from above, will reflect off that surface. So here we have the waves being reflected by, say, if this was the ocean, a concrete barrier. Now you'll notice that the angle they went in at is equal to the angle they come back out at. Now, that's not something on the combined AQA paper, but it's useful to know that the angle of incidence, that's the angle it comes in at, is the same as the angle of reflection. Now finally, thinking about the fact that all waves can be reflected, when you hear a reflected sound wave, we call that an echo. When we see a reflection of ourselves, we just call it a reflection as normal, but it's something we might see in a shiny object. However, when you look at all objects, they are all reflecting some light. It's just that a mirror happens to reflect the light in a way that allows us to see an image, whereas other materials, they've got rough surfaces, and so the light is scattered in all directions, and so it allows us to see those objects, but we don't see an image in those objects. We don't see a reflection, even though they are actually reflecting the light that's hitting them. Now let's take a look at refraction. So here we have a grey fluid followed by a blue fluid. In the grey fluid at the top, what we're showing is a group of waves being aimed at the boundary between the grey and the blue, or the interface. So we could call this a boundary or an interface, and that's the place where they meet, where the grey and the blue fluids meet. Now you'll notice that when that grey fluid, the waves in it, arrive at that boundary, some of those waves are reflected and stay in the grey, but some of them are refracted. And you'll notice when they're refracted, they have changed direction. This is because, if you notice very carefully in the blue, the waves are travelling more slowly. So the waves in the grey are travelling very fast. The waves in the blue are travelling more slowly. Because of that, they change direction. So let's look at how we need to talk about refraction in the exam. Refraction defined? Well, if it asks for the definition of refraction, that's when a wave changes direction as it enters a new medium. So in the previous example, it went from a grey medium into a blue medium. Refraction described. Okay, again, this is waves change direction at the boundary between two media. Media is the plural of medium. So waves change direction at the boundary. Now that's a description of refraction, and we need to be very careful when we're in our exams not to confuse a description with an explanation, because an explanation needs the word because. So here we start with our description, waves change direction at the boundary between two media, but we need to add on because the waves change speed as they enter the new medium. Pause the video if you need to copy that down, or you can always print screen. Finally, let's look at how we might apply that to water waves. Refraction of water waves described. Water waves change direction when they move from shallow to deep water, or you could say from deep to shallow water. Either way is fine. So water waves change direction when they move from shallow to deep water. And refraction of water explained, waves change direction as the depth of water changes. Now we need to add in the word because, due to it being an explanation question. So, because waves travel more slowly in shallow water. And that is the basics of refraction and reflection that you need to know for your combined science higher physics paper with AQA.